Is flow net is drawn for a two-dimensional boundary. Two-dimensional boundary flow net is drawn if you take in terms of 3D. So the size of square side is 1.2 centimeter and the velocity of uniform flow size is given as 1.2, velocity is zero point 0.5 meters per second. At one approach, this is dissipation, we can say approach and dissipation. The size of the square at the other location in the stream tube is 0.5 centimeters. S is given as 0.5 centimeters. We have to find out the velocity. So according to the whatever the discharge that is coming in, that must go out according to the discharge continuity equation. Q is equal to A1 V1 is equal to A2 V2. Area of the square 1.2 squares into 0.5 divided by 0.5 square is equal to velocity V2. So V2, from this equation we know that V2 is equal to 2.88, right, meters per second. So here option C is correct. If the risk of flood occurring in the next 10 years accepted at 10%, so not accepting is 0.9%. Then the return period, we have to find out the return period, that is or T, return period we can say it as T. So we know that not occurring 1 minus P whole power 0.1, that is equal to whole power 10, it is equal to P is equal to 1 minus 0.9 whole power 0.1. Therefore return period T is equal to 1 by P, that is equal to 1 by 1 minus 0.9 whole power 0.1. It is equal to option C is correct. A laminar flow is taking place through a pipe of diameter 2 meters is given. Diameter of the pipe is 2.0 meter is given. Having a maximum velocity at the center line is given as Vmax is given as 6 meters per second. What will be the discharge through the pipe? We have to find out discharge through the pipe. Discharge through the pipe, Q is equal to AV, where V is average velocity. So V average is equal to half of Vmax. We know that half of Vmax is 3 meters per second. So by substituting V average over here in the equation 1, Q is equal to pi by 4 d square is 2 square into 3, that is equal to 3 pi. Option C is correct. The electrostatic precipitators are nowadays installed in the thermal power plants to remove from its gaseous emission which are the following. From the thermal power plants we use it to get the waste material as fly ash. So to remove that, the electrostatic precipitators are nowadays we are using. So option A is correct. If a sample of air analyzed at standard temperature and pressure is found to be contained 0.3 ppm parts per million of SO2 sulfur dioxide, then the equivalent SO2 concentration in micrograms per cubic meter. The equivalent SO2 concentration in micrograms per cubic meter is given as SO2 in ppm into 6400 divided by 24.04, that is equal to 0.3 into 6400 divided by 24, that is equal to 800. So option B is correct. Option is, if the self purification constant of a large stream flowing with velocity is 3 meters and reoxygenation coefficient is given as 0.3, then deoxygenation coefficient we have to find out. So we know that self purification constant is equal to K reoxygenation by K deoxygenation. This self purification constant is given as 3, K reoxygenation constant is given as 0.3. We have to find out the deoxygenation constant. So K deoxygenation constant is equal to 0.3 by 3, that is equal to 0.1. So option C is correct. The question is find the loss of energy in the hydraulic jump where the conjugate depth before and after jump were given. So we have to find out the loss of energy is equal to y2 minus y1, the conjugate depths whole cube by 4y1 y2. Y2 is after jump and y1 is before jump, the conjugate depth. So 2.5 minus 0.5 whole cube divided by 4 into 2.5 into 0.5, that is equal to 1.6 meters. So here all the options has to be in meters. So option C is correct. So we have to find out the volume of the embankment by using the Fresnoidal formula. So the given data is the cross-sectional area of an embankment at 30-meter interval is given as 20, 40, 60, 50 and 30 square meters respectively. Then the volume of the embankment we have to find out by using Fresnoidal formula. Volume is given by interval, we can say it as L divided by 3 into area, initial area, final area plus 4 into in between, A2 plus A4 plus and so on, plus 2 times of A3, A5 plus and so on. So by substituting over here, L is 30 by 3, A initial 20 plus 30 plus 4 into A2 is 40 plus initial final 2, 3, 4. 4 is 50 plus 2 into 60, that is equal to 5300 cubic meters. So option A is correct. Is a transition curve is required for a circular curve of radius r is given as, we will extract the data from the question was given. The gauge length is given as 1.5 meters and the maximum super elevation E is given as 15 centimeters, that is equal to 0.15 meters. The transition curve is to be designed for a velocity such that no lateral pressure is imposed on the rails, and the rate of gain of radial acceleration A is given as 30 centimeters per second square, and the required length of transition curve will work out to be, we have to find out the required length of transition curve. So the transition curve is to be designed for a velocity such that V square is equal to E by ZL into G into R. GL is gauge length. Gauge length. So by substituting these values over here, that is equal to, we will get 14 meters per second. V is given, we will get it as 14 meters per second. So the length of the transition curve L is equal to V cube by radial acceleration A into radius of the curve, or V 14 cube divided by A is 30 centimeters, that is 0.3 meters per second square, into radius is 200 meters, that is equal to 46 meters approximately. So 46 meters